Hi, this is Professor Sanyal. In this video, I'm going to provide a brief introduction to the RapidMiner Studio interface. I'm also going to show how to import a dataset and build a simple process. The version of RapidMiner Studio that I'm using is 9.3 and I'm running the software on a Windows machine. After you have downloaded and installed RapidMiner and open it up, this is the first screen that you are going to see, which says Welcome to RapidMiner Studio. Now, when you are working on advanced projects using RapidMiner Studio, you may need to use some of the items on this screen, such as the templates over here. But in most cases, you can close this screen and start your work from this main RapidMiner Studio screen. Now, I want you to focus at the top first, where you see these views: design, results, turbo prep, and auto model. The two main views that we are going to devote most of our time when using RapidMiner Studio are the design view and the results view. Design view is what is open in RapidMiner Studio by default. This is where we are going to build our models, and the results view is where the results of the processes are going to be displayed. We can switch between these two views by simply clicking the button. So for example, I can click the results view button and I'm in the results uh, view, and I can click the design view button and go back to the design view. Now, the other two views, turbo prep and auto model, we are only going to need if you are working on advanced projects using RapidMiner. The design view is divided into several panels. At the center of the design view is the process panel, where we are going to build our processes. To the left of the process panel is the repository, which is which helps us organize our data and processes. So for example, I have created several repositories for my work, such as research, teaching, and my tutorial. But for any RapidMiner Studio installation, the local repository is created by default. So when you install RapidMiner Studio, you will see that a local repository has been created. Now below that is the operators panel, where all the operators are provided. Now these are like the methods that we are going to use to develop our models. So for example, if we want to build a regression model, we might need to use the regression operator, which we can find under modeling, predictive modeling, and functions. We can see the linear regression operator. When we click on any of these operators, the corresponding help is provided on the bottom right panel over here, which says help. And above the help panel are the parameters panel, which we are going to need when we build some processes. So I'm going to close this operator over here. Okay, so we now know what are some of the items on the main RapidMiner Studio screen are. Now we can change the this view in the sense that we can move around repositories. So for example, we can move around panels. So for example, we can move the repository panel from the left to the right. We can close the operators panel if we want to increase the size of our process area. We can expand the help panel like this. We can expand the size of our process panel like this. But at any time we want to go back to the default location of the panels, we can always go to view and say restore default view. Once we click here, all the panels will be put back to their default positions. Now I like to create two folders within the local repository in order to store my data and my processes, so that the data sets that I import to RapidMiner and the processes that I build in RapidMiner are kept separately. In order to create folders in in our repositories, we can select that repository and then say create subfolder. So the two subfolders that I typically create in a repository are data, and I'll create one more subfolder and I'm going to call it processes. So I like to create these two subfolders so that I can store all my data sets in the data subfolder and store all my processes in the processes subfolder. Now the connections that you see over here, it's for database connections. That's what the folder is for, but we are not going to use that folder now. Now that we have created the two subfolders, data and processes, I'm going to import our data set into RapidMiner Studio. To import a data set, we can click this button over here that says import data. And I'm going to, the data set that I'm going to use is not from a database, but rather it's a spreadsheet that is on my computer. So let's click on my computer. And I have a data set called Toyota Corolla over here, which is the one that I'm going to use. So this is the one that I'm going to import to RapidMiner Studio by clicking next over here. This is the data set. Now, the spreadsheet Toyota Corolla that you just saw has two worksheets. One which is called the data, which is what is selected by RapidMiner by default. And the other worksheet that I have on that same file is called variables, which provides the description of all the attributes in the data file. Now we can choose, suppose your file has a number of worksheets, you can choose which data or which worksheet you want to import into RapidMiner. In this case, obviously, I want to import the data worksheet, that is the worksheet that has the data. And so I'm going to choose that particular sheet. And the range is by default chosen in such a way, is selected in such a way that your entire data set is selected. So in this case, I have a data set that has, I think, about 1000 rows. It has 1000 rows, 1001 because there is a header row at the top. And I want to select all these records. So I'm going to select, hit next over here. Now the next screen that you see, RapidMiner Studio has tried to uh, put a type for each of the attributes on this data set. So it has, based on the data that it sees. So for example, there is a price variable where the prices of the cars are. There's an age variable where the age of the car in months are given, which have been correctly identified as integer by RapidMiner. The price has been identified as integer, whereas the model names have been identified as polynomial. Now we can change any of the type if we don't like the type by hitting the arrow. So for example, let's say I don't like the type of the price. I can go here and say change type to some of the other things that are over here. But obviously in this case, RapidMiner has correctly put the type as integer, so I don't need to change it to anything else. I can also remove an attribute. So for example, if I don't want to import the price attribute, I can do that. I can select exclude column, but there are other ways of doing it also after I have imported it in RapidMiner. So I'm going to leave these as is, and I'm not going to change anything, but I'm going to hit next over here. And then it says, where do you want to store the data? Now, I want to store the data in the data subfolder that I just created in my local repository. So I'm going to select data, and we can change the name of the data set if we want. We can give any other name that we want. But for the time being, I'm not going to change the name. I'm going to keep it Toyota Corolla and say finish. So by default, RapidMiner has switched from the design view to the results view in order to show us the content of the dataset. Now, let me explain what this dataset is about. So this dataset contains, as you saw, 1000 rows uh, of Toyota Corolla cars. These are used Toyota Corolla cars, and it has data on the properties of these cars, such as what was the age of the car when the car was sold, what was the manufacturing month, year, what was the mileage on the cars, what was the fuel type of the car, what was the color of the car, whether it had automatic or it did not have automatic, 0 if it did not, 1 if it did, and then it has the price, that is the price that these used cars were sold. Now, this is a data set from the Netherlands, so the price is in euros. Now, on the left, you will see the data, which is the default. But if we want to look at some of the statistics of this data set, we can click the statistics icon over here, and it shows some basic statistics on all the attributes. So for example, for the price attributes, we can see easily that the car in this data set that has the minimum price, that is, it's sold for the least amount, was a car that was sold for 4,350 euros. The highest valued car in this data set is the 32,500 euros. And the average price of the cars in this data set is 11,860 euros. Um, the age of the car, which is in months, the minimum is 1, the maximum is 68. The average age of the car in this data set is about 48 months, which is 4 years. And mileage on the cars, you can see. Now for the categorical variables, such as the fuel type, it also shows what is the how many cars of each type there are. So for example, I can click here and I can click on the details, and it shows that there are 3 types of cars in terms of fuel type in this data set. There are 867 cars which are petrol, 119 cars in diesel, and 14 cars that run on natural gas. And here are the percentages also. That is, since there are 1000 cars in this data set, the percentage, calculating the percentage from the counts is fairly easy. We can also see some visualization of these 3 types of cars. So if we click on open visualization, it shows that there are about 119 cars with diesel, which we already saw, 867 cars on petrol, and the rest on gas. Now we can change the visualization also. So also see that when I clicked on visualization, RapidMiner brought me automatically to this visualization part. Um, and by default, it showed the bar chart of the fuel type, but I can change it to pie chart, for example. Let's change it to pie chart. And we can quickly see the pie chart of the 3 fuel types, that is petrol, diesel, and natural gas. Now we can go back to our data part, which by clicking the data, and we can go back to our design view by simply clicking the design. Now once we have gone back to the design view, we can go back to the results view to look at the data by simply clicking the results. Now, and then by clicking the design, we can go back to the design. We can also, at any point, if we want to look at the data set, we can always double click on this data set, and that data set, even if it was not opened, it will be open. And then we can look at the data set, and we can um, build other visualizations also. So for example, the visualization, let's say we want to look at the relationship between the age of the car and the price of the car. We would imagine that as the age of the car increases, the price of the car decreases. So suppose we want to look at that scatter plot. We can change the plot to scatter plot, and suppose the x-axis is the age of the car and the value column is the price of the car. So fuel type is already selected, so I'm not going to need fuel type for this visualization. So I'm going to remove fuel type, and I'm only going to keep price and say apply. So RapidMiner quickly draws a scatter plot of price against the age of the car. So on the x-axis you see the age of the car, on the y-axis you see the price of the car, and not surprisingly there is an inverse relationship, that is, as the age of the car increases, the price of the car seems to decrease. Now we can add another dimension to this graph by selecting color dimension. So for example, let's say what about the fuel type of these cars? So we can put a color code, and so the color code is the petrol is the green, the diesel is the blue, so and orange is the natural gas. So it looks like that the few most expensive cars are all diesel cars. And we can also add the size dimension by including another variable in the size attribute, for the size attribute. Okay, so we now know how to open a data set, how to import a data set, how to look at the characteristics of the data set, how to look at some basic statistics using the data set, and also how to create some quick charts and graphs to look at the properties of the data set. Let's now go back to design and try to build our first process using RapidMiner Studio. To build a process, we have to first bring the Toyota Corolla dataset over here. So in this operator, you see this part over here, which is called an output port. Now this dataset in the output port has the data going out of this operator. So if I put my cursor over here, you'll see the metadata of the Toyota Corolla dataset. And this is referred to as the spline or the wire, which is connected to the results port. So the results port is shown here, and anything that we want to display in the results, we have to make sure that we put them in the results port. So in this case, this is already a process that we have built, which does nothing but puts the dataset into the results port. So we can actually go ahead and run this process by clicking this button over here that looks like the play button. So once we have built a process, we can run that process by clicking this play button. So let me click this button. And so now the RapidMiner process has been run, and the process is obviously nothing but to display the dataset in the results. But now we are going to go back to the design view and build a little more advanced process, which is to generate the correlation metrics for the data in the Toyota Corolla dataset. So to create the correlation metrics, which shows the correlation among all the variables in the dataset, we are going to need an operator, which is the correlation operator. Now we can try to find where the correlation operator is by going into the utilities folder and then within that to another subfolder. But actually RapidMiner provides a nice search over here where we can search the operator that we need. So in this case, I'm going to search for correlation, and we see that here is all the correlation operators, and the one that I'm going to use for this function is the correlation matrix operator. Now we can drag the correlation metric operator over here, or we can simply double click on the correlation matrix and it is put in the design panel. And by default, RapidMiner has added all these uh, splines or wires from the output ports to the results port over here. But I'm going to need, in this example, I'm going to use the metrics output port, but not the weight output port. So I'm going to delete that output port. Okay, so I deleted both the output ports, but I can go ahead and add the wires by myself. So let me show how to add the wires or wiring by ourselves. So first of all, we need to put the output of the dataset into the input port of this correlation matrix operator. So while the dataset had only one port, which is one output port, it didn't need any input. The correlation matrix needs an input through this input port, and it can generate three different types of output, which comes out of these three output ports over here. Also see that this has a red color on this input port, which means this is a mandatory port. If I put my cursor over here, you will see that it says that mandatory input missing. So any port which is mandatory, it has a red color, and we need to populate that port. In this case, we need to populate this port with the data coming out of the output port of this operator. So I'm going to click here and then drag that input or drag that output into the input port. So now we have provided the mandatory input that was needed for the correlation matrix operator, and therefore the red color is now gone. But now we have to put the output from the correlation matrix if we want to see the correlation matrix. The correlation matrix is available from this matrix port. See, it says correlation matrix. So we can put this correlation matrix output port or connect the correlation matrix output port to the results port. Excuse me. So now our process is complete. We have provided the input to the correlation metric, and we have put the output of the correlation matrix operator into our results. Also, if you want to see what the correlation matrix does, we can click on the correlation matrix operator. So it is selected, and the description of the operator is provided here on the right bottom right corner for the variables, and we can drag and increase the size of this panel, and we see that all the description of what this matrix does. If you are curious about what these other output ports are for in this operator, you can look at what they do. So here it is. It has three output ports. One is the example set, which is at the top, the matrix, which is at the middle, which we need for our purpose, and there is a weights output port also at the bottom, and it describes what it does. So okay, so we have built our first process. Now we are going to run the process. And again, we can run this process by simply clicking on the button over here. So let's click this button. So here is our correlation matrix. Um, and we can see that the metric shows the correlation between pairs of all the variables in the data set. So for example, some of the correlation doesn't make much sense, but some of the correlations might be interesting. So for example, the correlation between price of the car and the age of the car could be found here, which is negative 0.868, which is a high negative value, which means there is that age and price are highly negatively correlated, which is what we should expect, because as the age of the car increases for used cars, the price of the car decreases. Similarly, if we look at the correlation metrics for the price and the mileage of the car, which is over here, it also has a fairly high negative correlation. That is, the more the mileage on the car, the lower is the price of the car. So that was our first process in RapidMiner. And again, if you by mistake, suppose you close this correlation matrix and close the other results that we generated earlier, we can always go back to our design view and run the process, and our correlation matrix will be created again. Okay, so the last thing I want to show is to save this process. So if we try to close RapidMiner now, it's going to say, do you want to save changes to the unnamed, which we obviously want. So I'm going to cancel this dialog box, and I'm going to save this process first. So to save this process, I can go to File and say Save Process As. So save process as, I'm going to save the process in my processes subfolder. As I said, I like to keep my data and my processes separately. So we kept the Toyota Corolla data set in the data subfolder, and I'm going to save this process in the processes subfolder. So I'm going to put a name to the process. Let's say this is correlation using Toyota Corolla. So this is the name I give to the process, and then I say okay, and now my process is saved in the processes subfolder. And also see that the data has this kind of an icon in RapidMiner, and the processes have this kind of an icon in RapidMiner. Now even if you close this process, you can always reopen. So suppose I close RapidMiner and then come back to RapidMiner, I can always open the RapidMiner process by double clicking on this, and it will open the process. Now, one last thing I want to show in this video is what is the location of the processes or the process that we just created, and how is it stored in our local machine. So if I right click on the correlation process, it shows a menu which has something called open in file browser. So if I click here, it shows that how the process is stored on my local machine. So RapidMiner has created two files corresponding to this process. One is a properties file, and other file, which is the more important file, is the .rmp file, which represents RapidMiner process. So if you don't know where your process is saved, you can always do what I just did, that is right click and open the file in the file browser, and then look at the file that was created corresponding to your process. Okay, so that's all for this video. Thank you all so much for your attention.